Question 1. Market research demonstrates that a company is collecting a large volume of unstructured customer feedback through various channels. This feedback includes comments, suggestions, and complaints, each varying in length and content. The data science team needs to store this feedback initially in a Python environment to prepare it for sentiment analysis and topic modeling. Which Python data structure is most appropriate for storing this raw, diverse textual data to facilitate subsequent processing? Option A. A list of strings where each string represents a single piece of customer feedback. Option B. A tuple of strings where each string represents a single piece of customer feedback. Option C. A dictionary where the keys are unique identifiers and the values are strings representing customer feedback. Option D. A set of strings where each string represents a single piece of customer feedback. Correct answer is A. A list of strings where each string represents a single piece of customer feedback. Explanation. Scenario analysis. This scenario is professionally challenging because it requires a data scientist to select the most appropriate Python data structure for storing and manipulating diverse, unstructured textual data, such as customer feedback. The challenge lies in balancing efficiency, flexibility, and the ability to perform various analytical operations without prior knowledge of the exact nature or volume of the feedback. Incorrect choices can lead to performance issues, difficulties in data processing, and ultimately hinder the insights derived from the research. Correct approach analysis. Storing customer feedback, which is inherently unstructured and can vary in length and content, is best handled by a Python list of strings. A list provides a flexible, ordered collection that can accommodate an arbitrary number of feedback entries. Each string within the list can represent a single piece of feedback, allowing for easy iteration, appending new feedback, and applying string manipulation methods or natural language processing (NLP) techniques. This structure is fundamental for initial data ingestion and preparation, aligning with best practices for handling raw, variable text data before more structured analysis. Incorrect approaches analysis. Using a Python dictionary to store customer feedback where each feedback item is a key would be inefficient and semantically incorrect. Dictionaries are designed for key-value lookups, and feedback entries are unlikely to have unique, meaningful keys that would facilitate efficient retrieval. Attempting to use feedback text as keys would lead to issues with duplicate entries and performance degradation. Furthermore, if the feedback itself is the value, it doesn't offer any advantage over a list. Employing a Python tuple to store the customer feedback is also inappropriate. Tuples are immutable, meaning once created, their contents cannot be changed. Customer feedback is typically an ongoing stream, and the inability to add new feedback or modify existing entries makes a tuple unsuitable for this dynamic data collection process. Opting for a Python set to store customer feedback would automatically remove duplicate entries. While deduplication can be a useful step in data cleaning, it's not the primary requirement at the initial storage stage. The goal is to capture all feedback, including potential duplicates, to understand the full spectrum of customer sentiment. Removing duplicates prematurely might lead to a loss of valuable information about recurring issues or opinions. Professional reasoning. Professionals should approach data structure selection by first understanding the nature of the data and the intended operations. For raw, variable length, and potentially numerous textual entries like customer feedback, a dynamic and ordered collection is paramount. The decision-making process involves considering 1. Data mutability. Can the data be added to or modified? 2. Data ordering. Is the sequence of data important? 3. Data uniqueness. Are duplicates to be preserved or removed? 4. Access patterns. How will the data be retrieved and processed? For customer feedback, a list of strings best satisfies the requirements for mutability, flexibility in handling varying text lengths, and the ability to iterate through all entries for subsequent analysis. Question 2. Assessment of Python code optimization strategies for data processing pipeline handling large datasets, considering both performance and maintainability. Option A. Relying exclusively on deeply nested for loops for all data transformations, prioritizing simplicity of syntax over processing efficiency for large datasets. Option B. Integrating numerous obscure Python hacks and one-liner tricks to condense code, without regard for how easily other developers can understand or debug it. Option C. Employing vectorized operations with libraries like NumPy and Pandas, utilizing list comprehensions for iterative tasks, and profiling code to identify and address actual performance bottlenecks. Option D. Implementing complex, custom C extensions for all data manipulation functions to achieve maximum computational speed, even if it significantly reduces code readability. Correct answer is C. Employing vectorized operations with libraries like NumPy and Pandas, utilizing list comprehensions for iterative tasks, and profiling code to identify and address actual performance bottlenecks. Explanation: scenario analysis. This scenario presents a common challenge in data science projects, optimizing code for efficiency without compromising readability or maintainability. The professional challenge lies in balancing performance gains with the long-term health of the codebase, especially in a collaborative environment where multiple developers might interact with the code. Careful judgment is required to select optimization techniques that are appropriate for the scale and complexity of the data and the project's lifecycle. Correct approach analysis. The correct approach involves leveraging Python's built-in functions and optimized libraries like NumPy and Pandas for data manipulation. These libraries are implemented in C and are highly optimized for numerical operations, offering significant performance improvements over pure Python loops for large datasets. Using list comprehensions or generator expressions where appropriate also provides a more concise and often more efficient way to create lists or iterate over sequences compared to traditional for loops. This approach represents best professional practice because it prioritizes efficient, idiomatic Python, which is generally more readable and maintainable. It aligns with the principle of using the right tool for the job, where specialized libraries are designed for performance-critical tasks. This also indirectly supports ethical data handling by ensuring that processing is done efficiently, reducing computational waste and potentially faster delivery of insights. Incorrect approach is analysis. One incorrect approach would be to prematurely optimize by writing complex, low-level C extensions or using highly obscure Python tricks that significantly reduce code readability. This fails professionally because it violates the principle of maintainability and collaboration. Code that is difficult to understand or debug increases the risk of errors and slows down future development. It can also lead to ethical concerns if the complexity obscures potential biases or errors in the data processing logic. Another incorrect approach is to simply use nested for loops for all data processing tasks, regardless of dataset size. While this is readable, it is professionally unacceptable for performance-sensitive applications. For large datasets, this can lead to extremely long processing times, making the solution impractical and potentially hindering the timely delivery of critical insights. This inefficiency can also be seen as a failure to responsibly manage computational resources. A third incorrect approach might involve relying solely on external, unverified libraries without understanding their underlying implementation or potential performance bottlenecks. This can lead to unexpected performance issues or introduce subtle bugs that are difficult to diagnose, undermining the reliability of the data science solution. Professionally, this demonstrates a lack of due diligence in selecting tools. Professional reasoning. Professionals should approach code optimization by first profiling their code to identify actual performance bottlenecks. Then, they should consider optimizations that offer a good balance between performance gains, readability, and maintainability. This often involves using standard, well-documented libraries and idiomatic Python constructs. When considering more advanced optimization techniques, it's crucial to document them thoroughly and ensure that the team understands the trade-offs. The decision-making process should prioritize solutions that are robust, scalable, and easy for others to understand and contribute to, ensuring the long-term success and integrity of the data science project. Question 3. Which approach would be most appropriate for a data science team tasked with developing a new customer segmentation model that aims to improve marketing campaign effectiveness while also ensuring fairness and avoiding discriminatory outcomes? Option A. Prioritize rapid model development and deployment to capture market opportunities, with a plan to address any potential bias issues only after the model has been in production for a significant period. Option B. Focus on achieving the highest possible predictive accuracy, assuming that a statistically optimal model will inherently be fair, and deferring any fairness considerations to a separate later review. Option C. Implement a comprehensive bias detection and mitigation strategy throughout the model development lifecycle, including data preprocessing, feature selection, model training, and post-deployment monitoring, with thorough documentation of all steps. Option D. Rely on the intuition of experienced team members to identify and address potential biases during the development process, without formal testing or documentation of fairness metrics. The correct answer is C. Implement a comprehensive bias detection and mitigation strategy throughout the model development lifecycle, including data preprocessing, feature selection, model training, and post-deployment monitoring, with thorough documentation of all steps. Explanation. This scenario presents a common challenge in data science projects, balancing the need for rapid deployment of insights with the ethical and regulatory obligations surrounding data privacy and responsible AI. The professional challenge lies in navigating the potential for bias in AI models, which can lead to discriminatory outcomes and reputational damage, while also meeting business demands for timely results. Careful judgment is required to ensure that the pursuit of innovation does not compromise fairness or compliance. The correct approach represents best professional practice because it prioritizes a systematic and ethical development lifecycle. This involves proactive identification and mitigation of bias through rigorous testing and validation, aligning with the principles of responsible AI development. It also emphasizes transparency and documentation, which are crucial for accountability and for demonstrating compliance with emerging AI regulations and ethical guidelines. This approach ensures that the data science team operates within established best practices for fairness, accountability, and transparency, thereby minimizing risks of unintended harm and regulatory scrutiny. An incorrect approach that focuses solely on speed without adequate bias checks fails to uphold the ethical imperative to prevent discrimination. This can lead to the deployment of models that perpetuate or amplify existing societal biases, resulting in unfair treatment of individuals or groups. Such a failure could violate data protection regulations that mandate fair processing of personal data and could expose the organization to significant legal and reputational damage. Another incorrect approach that neglects to document the bias mitigation process creates a lack of transparency and auditability. This makes it difficult to demonstrate due diligence in addressing potential fairness issues, which is increasingly a requirement under regulatory frameworks. Without proper documentation, it becomes challenging to identify the root causes of any future issues or to prove that reasonable steps were taken to ensure fairness, potentially leading to regulatory penalties and loss of trust. A further incorrect approach that relies on post-deployment monitoring as the sole method for bias detection is reactive rather than proactive. While monitoring is important, it should complement, not replace, pre-deployment bias assessment. Waiting for issues to arise in production can already have caused harm and may be more difficult and costly to rectify. This approach demonstrates a lack of foresight and a failure to embed ethical considerations into the core of the model development process, which is a hallmark of professional data science practice. Professionals should employ a decision-making framework that integrates ethical considerations and regulatory compliance from the outset of a project. This involves understanding the potential societal impact of the data science solution, actively seeking to identify and mitigate biases, ensuring transparency in methodology and outcomes, and maintaining thorough documentation. This proactive and responsible approach minimizes risks, builds trust, and aligns with the evolving landscape of data science ethics and regulation. Question 4. The review process indicates that a predictive model developed for loan application risk assessment has shown a statistically significant disparity in approval rates across different demographic groups, even after initial data cleaning. The data science team is under pressure to deploy the model to meet business targets. What is the most responsible course of action for the data science team? Option A. Proceed with deployment but document the observed disparities for future reference, without immediate corrective action. Option B. Implement bias mitigation techniques within the modeling phase to address the identified disparities before deployment. Option C. Halt the project indefinitely until a perfect, bias-free dataset can be procured, which may be impractical. Option D. Deploy the model as is, with a plan to monitor for bias, and address it through post-deployment adjustments if issues arise. The correct answer is B. Implement bias mitigation techniques within the modeling phase to address the identified disparities before deployment. Explanation. Scenario analysis. This scenario is professionally challenging because it involves a critical juncture in the data science process where a potential bias, if unaddressed, could lead to discriminatory outcomes and reputational damage. The pressure to deliver a functional model quickly can conflict with the ethical imperative to ensure fairness and equity. Careful judgment is required to balance the technical demands of model development with the societal implications of its deployment. Correct approach analysis. The correct approach, which involves identifying and mitigating bias during the modeling phase, represents best professional practice. This aligns with ethical guidelines that mandate fairness and non-discrimination in AI systems. Specifically, it reflects a commitment to responsible AI development, ensuring that the model's predictions do not disproportionately disadvantage certain groups. This proactive stance is crucial for maintaining trust and compliance with emerging regulations around algorithmic fairness. Incorrect approaches analysis. One incorrect approach involves proceeding with the model deployment without addressing the identified bias. This is a significant regulatory and ethical failure. It risks violating principles of fairness and equal opportunity, potentially leading to legal challenges and fines under data protection and anti-discrimination laws. Ethically, it demonstrates a disregard for the potential harm to individuals and groups affected by biased outcomes. Another incorrect approach is to dismiss the bias as a minor issue that can be handled post-deployment. This is also professionally unacceptable. Delaying bias mitigation shifts the burden of addressing harm to the end users or affected communities, which is ethically irresponsible. It also increases the complexity and cost of remediation later, and may not fully rectify the damage caused by initial biased decisions. Furthermore, it could be seen as a failure to exercise due diligence in the development process, potentially contravening professional standards. A third incorrect approach is to halt the project entirely due to the bias without exploring mitigation strategies. While caution is warranted, an outright halt without attempting to resolve the issue can be professionally inefficient and may represent a missed opportunity to develop a fair and valuable solution. It might also indicate a lack of expertise in bias mitigation techniques, which are a standard part of the data science process. Professional reasoning. Professionals should adopt a structured approach to bias detection and mitigation. This involves clearly defining fairness metrics relevant to the problem domain, systematically evaluating the model for bias at various stages of the data science lifecycle: data collection, feature engineering, model training and evaluation, and implementing appropriate mitigation techniques. When bias is detected, the professional decision-making process should prioritize addressing it before deployment, documenting all steps taken, and continuously monitoring for bias post-deployment. This iterative and responsible approach ensures that the data science solution is not only effective, but also ethical and compliant. Question 5. To address the challenge of an imminent project deadline, a data scientist discovers a subtle but potentially significant flaw in their error handling logic for a critical data processing pipeline. This flaw, if unaddressed, could lead to the misclassification of a small percentage of data points, potentially skewing downstream analytical results. The data scientist is under pressure to deploy the pipeline immediately. What is the most professionally responsible course of action? Option A. Immediately pause the deployment of the pipeline to thoroughly investigate and rectify the error handling logic, ensuring data integrity and accuracy before proceeding. Option B. Implement a quick, superficial fix to the error handling logic without comprehensive testing, prioritizing deployment over absolute certainty of resolution. Option C. Proceed with deployment and document the error handling flaw as a known issue, leaving it for a future iteration to address. Option D. Deploy the pipeline as scheduled, assuming the impact of the error handling flaw is negligible and will not significantly affect the overall project outcomes. The correct answer is A. Immediately pause the deployment of the pipeline to thoroughly investigate and rectify the error handling logic, ensuring data integrity and accuracy before proceeding. Explanation. Scenario analysis. This scenario is professionally challenging because it involves a direct conflict between the immediate need to deliver a project and the ethical imperative to ensure data integrity and transparency. The data scientist is aware of a potential flaw in their error handling that could lead to inaccurate results, but the project deadline is imminent. This creates pressure to overlook the issue, which could have significant downstream consequences for stakeholders who rely on the project's output. Careful judgment is required to balance project timelines with the responsibility to produce reliable and trustworthy data science solutions. Correct approach analysis. The correct approach, which involves pausing the deployment to thoroughly investigate and fix the error handling, represents best professional practice. In the context of data science, especially within regulated industries or when dealing with sensitive data, the principle of do no harm is paramount. This means ensuring that the models and analyses produced are robust, reliable, and do not lead to erroneous conclusions or decisions. Proactively addressing the error handling issue aligns with ethical guidelines that emphasize accuracy, integrity, and accountability in data science work. It also implicitly adheres to principles of good data governance, which require that data products are fit for purpose and have undergone appropriate validation. Delaying deployment to fix a known issue is a responsible act that prioritizes the quality and trustworthiness of the final product over short-term expediency. Incorrect approach is analysis. One incorrect approach would be to deploy the model with the known error handling issue, assuming it's a minor oversight that won't significantly impact results. This is ethically unacceptable because it knowingly introduces a risk of inaccurate outcomes. It violates the principle of integrity by not being transparent about potential flaws and the principle of accountability by not taking full responsibility for the quality of the work. This could lead to flawed business decisions, misallocation of resources, or even harm to individuals if the data is used in critical applications. Another incorrect approach would be to attempt a quick, superficial fix without proper testing. While seemingly addressing the issue, this approach is also professionally unsound. It risks introducing new, unforeseen errors or failing to fully resolve the original problem, thereby perpetuating the risk of inaccurate results. This demonstrates a lack of diligence and a failure to uphold the standards of professional practice in data science, which demands thoroughness and validation. A third incorrect approach might be to blame the data or the upstream processes for the error handling issue without taking ownership of the solution. While external factors can contribute to data quality problems, the data scientist is responsible for building robust error handling mechanisms within their own code. Shifting blame without actively seeking to resolve the issue within their control is a failure of accountability and professional responsibility. Professional reasoning. Professionals should adopt a decision-making framework that prioritizes ethical considerations and long-term project integrity. This involves 1. Identifying and acknowledging potential issues. Be aware of any limitations or potential flaws in your work. 2. Assessing the impact. Understand the potential consequences of these issues on stakeholders and the project's objectives. 3. Prioritizing quality and integrity. Recognize that delivering accurate and reliable results is more important than meeting a deadline at the expense of quality. 4. Communicating transparently. If a delay is necessary due to an issue, communicate this clearly and proactively to relevant parties, explaining the reasons and the plan for resolution. 5. Implementing robust solutions. Ensure that any fixes are thoroughly tested and validated before deployment. Question 6. The risk matrix shows that a proposed data science project involving customer sentiment analysis has a high likelihood of identifying valuable business insights, but also a moderate likelihood of inadvertently exposing personally identifiable information if not properly anonymized. What is the most responsible course of action for the data science team? Option A. Delegate the responsibility of PII risk management solely to the data science team without consulting legal or compliance departments. Option B. Prioritize the immediate extraction of business insights, assuming that the risk of PII exposure is manageable and can be addressed later if issues arise. Option C. Halt the project entirely due to the moderate risk of PII exposure, as any potential breach is unacceptable. Option D. Proceed with the project, implementing robust anonymization techniques and conducting a thorough privacy impact assessment before deployment. Correct answer is D. Proceed with the project, implementing robust anonymization techniques and conducting a thorough privacy impact assessment before deployment. Explanation. This scenario is professionally challenging because it requires balancing the potential benefits of a data science project with the inherent risks of data handling and analysis, all within the specific regulatory landscape of the IBM Data Science Professional Certificate. The certificate, while not a formal regulatory body itself, emphasizes best practices and ethical considerations that align with general data privacy principles and responsible AI development, which are increasingly codified in regulations like GDPR. Though we are strictly adhering to the exam's implied jurisdiction, which focuses on general data science principles without specific country mandates. The core challenge lies in making informed decisions about data usage and risk mitigation that are both effective for the project's goals and compliant with ethical data science standards. The correct approach represents best professional practice because it prioritizes a thorough understanding and documentation of potential risks before proceeding. This aligns with the principle of responsible data stewardship and proactive risk management. By identifying, assessing, and planning for mitigation of risks, data scientists demonstrate a commitment to ethical data handling, data privacy, and the integrity of their analytical outcomes. This proactive stance helps prevent potential data breaches, misuse of sensitive information, and biased or inaccurate results, all of which can have significant reputational and operational consequences. It also fosters trust with stakeholders and ensures the project's sustainability. An incorrect approach that solely focuses on the potential business value without adequately addressing identified risks is professionally unacceptable. This failure constitutes a significant ethical lapse and a potential regulatory violation in many data-intensive environments. It demonstrates a disregard for data privacy and security, increasing the likelihood of data breaches, unauthorized access, or discriminatory outcomes. Such an approach prioritizes short-term gains over long-term responsibility and can lead to severe legal penalties, loss of public trust, and damage to the organization's reputation. Another incorrect approach that involves ignoring or downplaying low-probability, high-impact risks is also professionally unsound. While it might seem efficient to focus on more immediate threats, neglecting potential catastrophic events is a critical oversight. This can lead to unpreparedness for unforeseen circumstances, resulting in significant financial losses, operational disruptions, and reputational damage if such an event occurs. It signifies a lack of comprehensive risk assessment and a failure to exercise due diligence in protecting data and ensuring project integrity. Finally, an approach that relies solely on the technical expertise of the data science team to manage all risks without involving relevant stakeholders or legal/compliance departments is flawed. Data science projects often intersect with legal, ethical, and business considerations that extend beyond technical proficiency. Failing to engage with these other areas can lead to overlooking crucial compliance requirements, ethical blind spots, and misaligned business objectives, ultimately jeopardizing the project and the organization. Professionals should adopt a structured decision-making process that begins with a comprehensive risk assessment. This involves identifying all potential risks, evaluating their likelihood and impact, and developing appropriate mitigation strategies. Crucially, this process should be collaborative, involving input from legal, compliance, and business stakeholders. Regular review and updates to the risk assessment are also essential as the project evolves and new information becomes available. This systematic and inclusive approach ensures that data science initiatives are conducted responsibly, ethically, and in alignment with organizational goals and regulatory expectations. Question 7. Operational review demonstrates that a relational database supporting critical business analytics is experiencing performance issues and data redundancy. A data scientist proposes to denormalize certain tables to improve query speed for analytical workloads. What is the most appropriate initial step to address this situation? Option A. Delete redundant data from existing tables and optimize individual queries without considering the overall database design principles. Option B. Implement a new indexing strategy across all tables to improve query performance without modifying the database structure. Option C. Immediately create new, aggregated tables that combine data from multiple existing tables to speed up analytical queries, without altering the original schema. Option D. Analyze the existing database schema, understand the relationships between tables, and assess the impact of denormalization on data integrity and existing applications before proposing specific changes. The correct answer is D. Analyze the existing database schema, understand the relationships between tables, and assess the impact of denormalization on data integrity and existing applications before proposing specific changes. Explanation. This scenario presents a professional challenge because it requires balancing the immediate need for data accessibility with the long-term integrity and security of relational databases. The data scientist must consider how changes to database structure can impact existing applications, reporting, and the accuracy of future analyses, all while adhering to principles of good database design and potentially data governance policies. Careful judgment is required to avoid introducing anomalies or inefficiencies that could compromise data quality or lead to compliance issues. The correct approach represents best professional practice because it prioritizes understanding the existing data model and its dependencies before making modifications. This aligns with the fundamental principles of relational database design, such as normalization, which aims to reduce data redundancy and improve data integrity. By analyzing the relationships between tables and the potential impact of changes on data consistency, the data scientist ensures that the database remains a reliable source of truth. This proactive approach minimizes the risk of introducing errors, breaking downstream processes, and ultimately ensures that the data remains fit for purpose for all stakeholders. Adhering to these principles also supports ethical data handling by maintaining data accuracy and preventing misinterpretations. An incorrect approach that involves directly altering table structures without understanding relationships or potential impacts is professionally unacceptable. This could lead to data anomalies, such as orphaned records or inconsistent data entries, violating the principle of data integrity. Such actions could also break existing applications or reports that rely on the current schema, causing operational disruptions and financial losses. From a regulatory or ethical standpoint, introducing data inconsistencies can lead to inaccurate reporting, which may have compliance implications depending on the industry and the nature of the data. Furthermore, making changes without proper documentation or stakeholder consultation demonstrates a lack of professional diligence and can erode trust among team members and stakeholders. Another incorrect approach, such as creating redundant tables to store similar information, directly contradicts the principles of normalization and efficient database design. This leads to increased storage requirements, potential for data inconsistencies as updates may not be applied uniformly across redundant tables, and makes data management more complex. Ethically, this is poor practice as it wastes resources and increases the risk of data errors. The professional reasoning process for similar situations should involve a thorough understanding of the existing system, clear communication with stakeholders, and a phased approach to any proposed changes. Before making any modifications, a data scientist should 1. Document the current database schema and understand the relationships between tables. 2. Identify the specific business or analytical problem that necessitates the change. 3. Assess the potential impact of the proposed changes on existing applications, reports, and data integrity. 4. Consult with database administrators and other relevant stakeholders. 5. Develop a plan for implementing and testing the changes, including rollback procedures. 6. Implement changes in a controlled environment and monitor for any adverse effects. This systematic approach ensures that decisions are data-driven, risk-aware, and aligned with professional best practices and ethical considerations. Question 8. Quality control measures reveal a statistically significant positive correlation between the frequency of a specific user interaction with a software feature and the likelihood of that user purchasing a premium upgrade. A regression analysis also indicates a strong predictive relationship. Which of the following approaches best ensures regulatory compliance and professional integrity when interpreting these findings? Option A. Focus exclusively on the R-squared value of the regression model to confirm the strength of the prediction, and then proceed with aggressive upselling tactics based on this statistical confirmation alone. Option B. Disregard the findings as a mere statistical artifact, assuming that correlation does not imply causation, and take no further action or investigation into the observed relationship. Option C. Immediately conclude that the user interaction directly causes the purchase decision, and use this as the sole justification for a targeted marketing campaign, promoting the premium upgrade to users exhibiting this interaction pattern. Option D. Conduct further exploratory data analysis to identify potential confounding factors, explore alternative explanations for the observed relationship, and consult with domain experts to assess the plausibility of a causal link before making any strategic decisions or claims. The correct answer is C. Immediately conclude that the user interaction directly causes the purchase decision, and use this as the sole justification for a targeted marketing campaign, promoting the premium upgrade to users exhibiting this interaction pattern. Explanation. Scenario analysis. This scenario presents a professional challenge, because it involves interpreting statistical findings in a context that has direct implications for regulatory compliance and consumer trust. The data science team has identified a correlation and is considering a regression model, but the potential for misinterpretation or misuse of these findings is high. The challenge lies in ensuring that the statistical analysis is not only technically sound, but also ethically and legally defensible, particularly when it might influence product development or marketing claims. The need for careful judgment arises from the potential for spurious correlations to be mistaken for causal relationships, leading to incorrect business decisions and potential regulatory scrutiny. Correct approach analysis. The correct approach emphasizes a thorough investigation into the underlying mechanisms and potential confounding factors before drawing conclusions or making recommendations based on the correlation and regression analysis. This aligns with best professional practices in data science, which prioritize scientific rigor and responsible interpretation. Specifically, it reflects a commitment to understanding the why behind the observed relationship, rather than simply accepting the statistical output at face value. This approach is crucial for regulatory compliance because it avoids making unsubstantiated claims or implementing strategies based on potentially misleading statistical association. It demonstrates due diligence in ensuring that any conclusions drawn are robust and can withstand scrutiny, thereby preventing potential violations of consumer protection laws or industry-specific regulations that prohibit deceptive practices. Incorrect approaches analysis. One incorrect approach involves immediately concluding that the identified correlation implies a causal relationship and proceeding to make product design changes or marketing statements based on this assumption. This is a significant regulatory and ethical failure because it risks making unsubstantiated claims. Many jurisdictions have regulations against misleading advertising and product claims. Mistaking correlation for causation can lead to a violation of these laws, potentially resulting in fines, reputational damage, and loss of consumer trust. Another incorrect approach is to dismiss the findings entirely due to the complexity of establishing causality without further investigation. While caution is warranted, completely ignoring a statistically significant correlation can be a missed opportunity for valuable insight, and may also be professionally negligent if the correlation points to a genuine, albeit complex, underlying issue that could be addressed. Ethically, it represents a failure to fully explore data that could lead to product improvement or a better understanding of customer behavior. A third incorrect approach is to focus solely on the statistical significance of the regression model, without considering the practical significance or the interpretability of the coefficients in a real-world context. This can lead to decisions based on statistically valid but practically meaningless relationships, or worse, relationships that are statistically significant due to overfitting or other modeling issues, which can still lead to regulatory issues if they result in flawed product development or marketing. Professional reasoning. Professionals should approach statistical findings with a critical and investigative mindset. The decision-making process should involve 1. Understanding the context and potential implications of the findings. 2. Rigorously examining the data and the statistical methods used, including exploring potential confounding variables and assessing the plausibility of a causal link. 3. Consulting domain experts to validate interpretations. 4. Considering the practical significance and interpretability of the results. 5. Documenting the entire process, including assumptions and limitations. 6. Ensuring that any conclusions or recommendations are supported by robust evidence and comply with all relevant regulations and ethical guidelines before being acted upon. Question 9. Consider a scenario where a data scientist working for a retail company has access to customer purchase history data, originally collected for order fulfillment and personalized marketing. The data scientist proposes using this data, along with publicly available demographic information, to build a predictive model for identifying customers who are likely to experience financial hardship in the near future, with the goal of offering them tailored financial assistance programs. The company has not previously informed customers that their purchase data might be used for such predictive modeling or obtained explicit consent for this specific secondary use. What is the most ethically and legally sound approach for the data scientist and the company to take in this situation? Option A. Use the raw, identifiable purchase history data and demographic information to build the model, focusing on the potential positive impact of the financial assistance programs. Option B. Proceed with building the predictive model using the existing purchase history data and publicly available demographic information, as the intention is to offer beneficial financial assistance. Option C. Anonymize the purchase history data by removing direct identifiers and then build the model, assuming that the insights will be used internally for program development. Option D. Obtain explicit consent from customers for the secondary use of their purchase data for financial hardship prediction and implement robust anonymization techniques to protect their identities before building the model. The correct answer is D. Obtain explicit consent from customers for the secondary use of their purchase data for financial hardship prediction and implement robust anonymization techniques to protect their identities before building the model. Explanation. Scenario analysis. This scenario presents a professional challenge due to the inherent tension between leveraging data for business insights and safeguarding individual privacy. The data scientist must navigate the complex ethical landscape of data usage, ensuring that the pursuit of innovation does not inadvertently lead to privacy violations or discriminatory outcomes. The professional challenge lies in balancing the potential benefits of advanced analytics with the imperative to uphold ethical standards and regulatory compliance, particularly when dealing with sensitive personal information. Careful judgment is required to identify and mitigate risks before they materialize. Correct approach analysis. The correct approach represents best professional practice because it prioritizes transparency, consent, and data minimization, aligning with core principles of data science ethics and privacy regulations. By seeking explicit consent for the secondary use of data and anonymizing it to prevent re-identification, the data scientist demonstrates a commitment to responsible data stewardship. This approach respects individual autonomy and adheres to the spirit and letter of data protection laws, which typically mandate informed consent and the protection of personal data. Incorrect approaches analysis. One incorrect approach fails by proceeding with the secondary analysis without obtaining explicit consent for the new use case. This violates the principle of informed consent, a cornerstone of data privacy. Individuals provided their data for a specific purpose, and using it for a different, unforeseen purpose without their knowledge or agreement is an ethical and regulatory breach. It erodes trust and can lead to legal repercussions under data protection frameworks. Another incorrect approach is to proceed with the analysis using the raw, identifiable data, assuming that the insights gained will be used solely for internal business improvement. This approach disregards the potential for re-identification, even with good intentions. The risk of accidental disclosure or misuse of identifiable information remains high, and it fails to implement robust privacy-preserving techniques. This directly contravenes the principle of data minimization and purpose limitation, often mandated by regulations. A third incorrect approach involves anonymizing the data superficially without a thorough assessment of re-identification risks. True anonymization requires more than just removing direct identifiers. It involves considering indirect identifiers and the potential for linkage attacks. Proceeding with a flawed anonymization process can create a false sense of security while still exposing individuals to privacy risks, leading to potential regulatory penalties and reputational damage. Professional reasoning. Professionals should adopt a risk-based approach, starting with a clear understanding of the data's sensitivity and the intended use. For any analysis, especially secondary use, they must identify relevant ethical guidelines and legal regulations, e.g., GDPR, CCPA, depending on the jurisdiction. The decision-making process should involve a thorough privacy impact assessment, exploring options for consent, anonymization, and pseudonymization. Transparency with stakeholders and clear documentation of decisions and their justifications are crucial. When in doubt, erring on the side of caution and prioritizing privacy is the most responsible course of action. Question 10. The investigation demonstrates that a data scientist is tasked with analyzing a large dataset to identify key drivers of customer churn for a telecommunications company. The data includes demographic information, service usage patterns, billing history, and customer support interactions. The data scientist needs to perform exploratory data analysis (EDA) to inform subsequent predictive modeling efforts. Which of the following approaches best aligns with professional best practices for conducting this EDA? Option A. Conduct a comprehensive EDA by systematically visualizing data distributions, exploring relationships between variables through scatter plots and correlation matrices, identifying outliers, and documenting initial hypotheses and observations before proceeding to model building. Option B. Focus exclusively on calculating summary statistics like mean, median, and standard deviation for all variables, without creating any visual representations of the data. Option C. Begin by immediately applying advanced machine learning algorithms to predict churn, using the EDA phase primarily to select features for the models. Option D. Selectively present only the EDA findings that strongly support the hypothesis that price is the sole driver of churn, omitting any data or patterns that suggest other contributing factors. The correct answer is C. Begin by immediately applying advanced machine learning algorithms to predict churn, using the EDA phase primarily to select features for the models. Explanation: scenario analysis. This scenario is professionally challenging because it requires a data scientist to balance the need for thorough exploratory data analysis, EDA, with the potential for misinterpreting or misrepresenting findings, especially when dealing with sensitive data or when the EDA is intended to inform critical business decisions. The pressure to deliver insights quickly can lead to shortcuts that compromise the integrity of the analysis. Furthermore, the implicit expectation that EDA will always yield clear, actionable insights can be misleading. Sometimes, EDA reveals complexity, ambiguity, or the need for further data collection, which can be difficult to communicate effectively. Correct approach analysis. The correct approach represents best professional practice because it prioritizes a systematic and iterative process of understanding the data's characteristics, identifying patterns, and detecting anomalies before drawing conclusions. This aligns with ethical data science principles that emphasize accuracy, transparency, and avoiding premature or unsupported claims. By focusing on visualizing distributions, identifying outliers, and exploring relationships between variables, the data scientist builds a robust foundation for subsequent modeling or reporting. This methodical approach minimizes the risk of drawing spurious correlations or making decisions based on incomplete or misunderstood data, thereby upholding professional responsibility and data integrity. Incorrect approaches analysis. One incorrect approach involves immediately jumping to complex modeling techniques without adequately understanding the data. This is a regulatory and ethical failure because it bypasses the crucial step of EDA, which is designed to inform model selection and prevent the application of inappropriate algorithms. It can lead to models that are poorly suited to the data, resulting in inaccurate predictions or insights, and potentially violating principles of responsible AI development by deploying systems that are not well understood or validated. Another incorrect approach is to focus solely on descriptive statistics without visualization. While descriptive statistics provide summary measures, they often fail to reveal underlying patterns, distributions, or outliers that are critical for a comprehensive understanding of the data. This can lead to a superficial understanding, missing important nuances that could significantly impact conclusions. Ethically, this represents a failure to conduct a sufficiently thorough analysis, potentially leading to misinformed decisions that could have negative consequences for stakeholders. A third incorrect approach is to selectively present only the most favorable findings from the EDA. This is a severe ethical and professional failure, bordering on data manipulation. It violates the principle of transparency and can mislead stakeholders into believing the data supports a particular conclusion when a more complete picture might suggest otherwise. This can have significant repercussions, including financial losses, reputational damage, and a breach of trust. Professional reasoning. Professionals should approach EDA with a mindset of discovery and critical evaluation. The decision-making process should involve 1. Defining clear objectives for the EDA in relation to the overall project goals. 2. Systematically applying a range of visualization and statistical techniques to explore data characteristics. 3. Critically assessing the findings, looking for both expected and unexpected patterns, anomalies, and potential biases. 4. Documenting all steps and observations thoroughly, including limitations and areas requiring further investigation. 5. Communicating findings transparently, highlighting uncertainties and the iterative nature of data analysis, rather than presenting definitive conclusions prematurely. This structured approach ensures that insights are grounded in a deep understanding of the data, promoting responsible and effective data science practice. Question 11. Upon reviewing an initial pandas data frame created from a newly acquired dataset for a predictive modeling project, a data scientist notices that several columns appear to contain personally identifiable information, PI, that was not expected or disclosed in the dataset's metadata. What is the most appropriate immediate course of action to uphold data privacy and regulatory compliance? Option A. Continue the data exploration and analysis as planned, making a mental note to address the PII later in the project if it becomes relevant to the model's performance. Option B. Proceed with the analysis, attempting to manually remove or mask the PII columns using pandas functions, assuming that this will adequately protect the data. Option C. Immediately stop all further data exploration and analysis involving this data frame and formally report the discovery of PII to the designated data governance or legal team for guidance on handling and remediation. Option D. Share the data frame with a colleague for a second opinion on whether the identified data is truly PII before taking any further action. The correct answer is C. Immediately stop all further data exploration and analysis involving this data frame and formally report the discovery of PII to the designated data governance or legal team for guidance on handling and remediation. Explanation. Scenario analysis. This scenario presents a common challenge in data science where the initial exploration of a dataset using pandas might reveal sensitive or personally identifiable information, PI, that was not anticipated. The professional challenge lies in balancing the need for data exploration and understanding with the imperative to protect individual privacy and comply with data governance policies. The urgency to address this discovery, without compromising the integrity of the analysis or violating ethical and regulatory standards, requires careful judgment. Correct approach analysis. The correct approach involves immediately halting further analysis that could expose PII, documenting the discovery, and consulting with the appropriate data governance or legal team. This represents best professional practice because it prioritizes data privacy and regulatory compliance. In the context of the IBM Data Science Professional Certificate, which emphasizes responsible data handling, this aligns with ethical guidelines that mandate protecting sensitive information. Promptly reporting such findings prevents potential data breaches and ensures that subsequent data processing adheres to privacy regulations, such as those that might be implicitly covered by the general principles of data protection and responsible AI development taught in the certificate. Incorrect approaches analysis. Continuing the analysis without addressing the PII is a significant regulatory and ethical failure. It demonstrates a disregard for data privacy principles and could lead to unauthorized disclosure of sensitive information, violating trust and potentially contravening data protection laws. Ignoring the discovery or attempting to fix it without proper oversight is also problematic. This approach bypasses established data governance protocols, which are designed to ensure that data handling is secure and compliant. Such actions could be seen as negligent and could have serious legal and reputational consequences. Attempting to anonymize the data unilaterally without understanding the full scope of the PII or the appropriate anonymization techniques could also lead to ineffective protection or even unintended re-identification, posing further privacy risks. Professional reasoning. Professionals should adopt a risk-based approach. Upon discovering potentially sensitive data, the immediate priority is to mitigate risk. This involves pausing the current activity, documenting the issue thoroughly, and escalating it to the relevant stakeholders, e.g., data privacy officer, legal counsel, project manager. This ensures that any further actions are taken with full awareness of the risks and in compliance with organizational policies and applicable regulations. A structured process of identification, assessment, and mitigation is crucial for responsible data science practice. Question 12. Risk assessment procedures indicate that a financial institution's trading data exhibits patterns that could potentially signal market manipulation. To investigate these patterns, a data science team is tasked with analyzing historical time series data. Which of the following approaches best balances the need for anomaly detection with regulatory compliance and ethical data handling? Option A. Apply standard statistical anomaly detection methods to the raw trading data without considering its temporal nature, focusing solely on identifying unusual data points. Option B. Analyze aggregated and anonymized trading data using time series decomposition and outlier detection algorithms to identify deviations from expected temporal patterns, while ensuring no personally identifiable information is retained. Option C. Smooth the time series data significantly to remove all minor fluctuations, thereby highlighting only the most prominent trends and reducing the risk of false positives. Option D. Directly analyze raw, individual client transaction data to pinpoint specific instances of suspicious activity, as this provides the most granular detail for investigation. The correct answer is B. Analyze aggregated and anonymized trading data using time series decomposition and outlier detection algorithms to identify deviations from expected temporal patterns, while ensuring no personally identifiable information is retained. Explanation. Scenario analysis. This scenario presents a professional challenge due to the inherent sensitivity of financial time series data and the regulatory environment governing its use. The core difficulty lies in balancing the need for robust data analysis to identify potential market anomalies with the imperative to comply with strict data privacy and security regulations. Misinterpreting or mishandling this data can lead to significant financial penalties, reputational damage, and erosion of client trust. The temporal nature of the data adds complexity, as patterns and anomalies can evolve rapidly, requiring timely and accurate detection. Correct approach analysis. The correct approach involves leveraging advanced time series analysis techniques to detect anomalies, while strictly adhering to data anonymization and aggregation protocols, as mandated by relevant financial regulations e.g. GDPR principles for data protection, and specific financial market conduct rules that emphasize data integrity and client confidentiality. This ensures that, while the data is analyzed for potential risks, individual client identities and sensitive transaction details are protected. The focus on identifying patterns indicative of market manipulation or systemic risk, without compromising privacy, represents best professional practice. This aligns with regulatory expectations for responsible data handling and risk management in the financial sector. Incorrect approaches analysis. An approach that prioritizes anomaly detection by directly analyzing raw, unanonymized individual transaction data fails to comply with data privacy regulations. This constitutes a significant ethical and regulatory failure, as it exposes sensitive client information to unauthorized access or misuse, potentially leading to breaches of confidentiality and trust. Another incorrect approach might involve over-aggregating or smoothing the time series data to such an extent that genuine anomalies, which could signal critical risks, become indistinguishable from noise. This would be a failure in risk assessment and potentially violate regulatory requirements for diligent market surveillance and risk identification. It demonstrates a lack of understanding of the trade-offs between data generalization and the need for granular insights into potential risks. A third incorrect approach could be to ignore the temporal dependencies in the data and treat it as static, applying general anomaly detection methods. This would be a failure to properly apply time series analysis principles, leading to inaccurate anomaly detection and potentially missing critical, time-sensitive risks. This demonstrates a lack of domain-specific knowledge and a failure to adhere to best practices in time series data science. Professional reasoning. Professionals in this domain must adopt a decision-making process that begins with a thorough understanding of the applicable regulatory framework, particularly concerning data privacy, security, and financial market conduct. This is followed by an assessment of the specific data characteristics and the analytical objectives. The chosen analytical methods must then be evaluated against both their effectiveness in achieving the objective and their compliance with regulatory requirements. A risk-based approach, where potential regulatory and ethical implications are considered at each stage of the data science lifecycle, is crucial. This involves consulting with legal and compliance teams when uncertainties arise and prioritizing data anonymization and secure handling throughout the process. Question 13. Examination of the data shows a large dataset of customer transactions across various product categories and geographical regions. A key objective is to present a summary of overall sales performance to senior management, who require a high-level overview. However, there are known significant differences in purchasing patterns between different customer demographics and distinct seasonal sales peaks that are crucial for understanding business performance. Which approach to data aggregation would best serve this objective while maintaining data integrity and professional responsibility? Option A. Aggregate sales data by product category and region, and further segment these by customer demographic and time period, e.g., monthly or quarterly, to highlight significant trends and variations. Option B. Aggregate sales data by the total number of transactions, without regard to the value of each transaction or any other distinguishing features. Option C. Aggregate sales data by product category and region, but present the overall average sales per customer without considering the timing of transactions or specific customer segments. Option D. Aggregate all transaction data into a single total sales figure, ignoring product categories, regions, and temporal variations. The correct answer is D. Aggregate all transaction data into a single total sales figure, ignoring product categories, regions, and temporal variations. Explanation. This scenario is professionally challenging because it requires balancing the need for concise reporting with the ethical imperative to avoid misleading stakeholders through oversimplification. The data scientist must ensure that the aggregated view accurately reflects the underlying trends and potential nuances, rather than obscuring them. Careful judgment is required to select aggregation methods that preserve essential information while achieving the desired level of summarization. The correct approach represents best professional practice because it prioritizes data integrity and transparency. By aggregating data at a level that still allows for the identification of significant variations or outliers within the broader categories, the data scientist upholds the principle of providing a truthful and representative overview. This aligns with ethical guidelines that discourage the manipulation or misrepresentation of data, even if unintentional. In a professional context, especially within the IBM Data Science Professional Certificate Framework, which emphasizes responsible data handling, this approach fosters trust and enables informed decision-making by stakeholders. An incorrect approach that aggregates data too broadly, losing critical distinctions between distinct customer segments with differing purchasing behaviors, fails to represent the reality of the data. This can lead to flawed strategic decisions, such as marketing campaigns that are ineffective for certain customer groups. Ethically, this is problematic as it can result in wasted resources and a misallocation of business efforts based on an incomplete or misleading picture. It violates the principle of providing accurate and actionable insights. Another incorrect approach that aggregates data but fails to account for temporal trends, e.g., combining sales data from a holiday season with regular periods without differentiation, can create a distorted view of performance. This misrepresents the underlying dynamics of the business and can lead to incorrect assumptions about future performance or the effectiveness of past initiatives. This is a failure in providing a contextually accurate representation of the data. A further incorrect approach might involve aggregating data in a way that masks significant outliers that represent critical events or anomalies. For instance, if a single large transaction heavily skews the average for a group, and this outlier is not addressed or noted, the aggregated figure becomes unrepresentative of the typical experience within that group. This can lead to a false sense of normalcy or stability, masking potential issues or opportunities. Professionals should employ a decision-making framework that begins with understanding the objective of the aggregation. What insights are stakeholders seeking? What level of detail is necessary to achieve that objective without being overwhelming? This involves considering the potential impact of different aggregation levels on interpretation and subsequent actions. It also requires a critical self-assessment of whether the chosen aggregation method might inadvertently obscure important information or create a misleading impression. When in doubt, it is often best practice to provide a more granular view or to clearly state the limitations and assumptions made during the aggregation process. Question 14. Performance analysis shows that the average customer engagement time across all users is 15 minutes. However, when examining the distribution of engagement times, a significant portion of users have engagement times of less than 5 minutes, while a smaller group has engagement times exceeding 30 minutes. Which of the following approaches best addresses the potential risks and ethical considerations associated with these descriptive statistics? Option A. Investigate the reasons for the wide variance in engagement times and analyze if this variance disproportionately affects specific user segments, considering potential fairness implications. Option B. Present the range of engagement times minimum to maximum without further analysis, as this provides a complete picture of the data spread. Option C. Focus on the most frequent engagement time mode to understand typical user behavior, as this indicates the most common experience. Option D. Report the average engagement time of 15 minutes as the primary metric, as it represents the central tendency of the data. The correct answer is A. Investigate the reasons for the wide variance in engagement times and analyze if this variance disproportionately affects specific user segments, considering potential fairness implications. Explanation. Scenario analysis. This scenario presents a professional challenge because it requires a data scientist to interpret descriptive statistics in the context of potential regulatory compliance and ethical consideration, specifically concerning data privacy and fairness. The challenge lies in moving beyond simply reporting numbers to understanding their implications for business decisions and potential risks. The data scientist must exercise careful judgment to ensure that the insights derived from descriptive statistics do not inadvertently lead to discriminatory practices or violate data protection principles, even if the raw data itself is not directly identifying. Correct approach analysis. The correct approach involves examining descriptive statistics like mean, median, standard deviation, and frequency distributions to identify potential biases or outliers that could indicate unfair treatment or disparate impact on different demographic groups. This aligns with the ethical imperative to ensure fairness and non-discrimination in data-driven decision-making. For instance, if the mean or median of a key performance indicator, e.g., loan approval rate, customer satisfaction score, significantly differs across protected characteristics, even if those characteristics are not explicitly stored but can be inferred or are present in aggregated data, it warrants further investigation. This proactive identification of potential issues before they manifest as systemic problems is a cornerstone of responsible data science practice and aligns with general principles of data ethics and responsible AI, which are increasingly being codified into regulatory frameworks. The focus is on understanding the asterisk distribution asterisk and asterisk central tendency asterisk of data to anticipate and mitigate risks. Incorrect approach is analysis. Focusing solely on overall averages without considering subgroup variations is an incorrect approach because it can mask significant disparities. For example, a high overall customer satisfaction score might hide a much lower score among a specific minority group, leading to a failure to address their needs and potentially violating principles of equal treatment. This approach fails to meet the ethical obligation of fairness and can lead to regulatory scrutiny if it results in discriminatory outcomes. Reporting only the most frequent values mode without context is also incorrect. While the mode indicates the most common occurrence, it provides no insight into the spread, central tendency, or potential skewness of the data. This limited perspective can lead to misinterpretations and a failure to identify critical patterns that might indicate risk or unfairness. It neglects the broader descriptive picture necessary for a comprehensive risk assessment. Presenting descriptive statistics without any interpretation or consideration of their potential impact on different user groups is an incomplete and professionally deficient approach. It abdicates the responsibility of a data scientist to provide actionable insights and to flag potential ethical or regulatory concerns. This passive reporting can inadvertently allow harmful biases to persist and grow, leading to reputational damage and potential legal repercussions. Professional reasoning. Professionals should adopt a risk-based approach to descriptive statistics. This involves not just calculating metrics, but actively questioning what those metrics reveal about the underlying data and its potential impact. The process should include 1. Understanding the data's context and purpose. 2. Calculating relevant descriptive statistics, mean, median, mode, variance, standard deviation, quartiles, frequency distributions. 3. Segmenting the data by relevant demographic or operational groups where ethically permissible and legally compliant to identify disparities. 4. Investigating outliers and unusual distributions for potential causes, including bias. 5. Communicating findings with a focus on potential risks and recommendations for mitigation, rather than just raw numbers. This systematic approach ensures that descriptive statistics serve as a tool for informed decision-making and risk management, upholding ethical standards and regulatory compliance. Question 15. The monitoring system demonstrates a need for enhanced data processing efficiency through the integration of new code components. Considering the absolute priority of adhering strictly to the regulatory framework, laws, and guidelines specified for the IBM Data Science Professional Certificate exam, which of the following approaches to implementing these components is most professionally sound? Option A. Integrate readily available open-source libraries and functions that offer significant performance improvements, assuming they are widely used and generally considered secure. Option B. Prioritize the fastest implementation of new code components to meet project deadlines, with a secondary, less rigorous review for compliance with the exam's regulatory framework. Option C. Utilize functions and modules from external, third-party vendors that claim to be compliant with general data protection principles, without specific verification against the IBM Data Science Professional Certificate exam's jurisdiction. Option D. Develop custom functions and modules internally, ensuring each is rigorously reviewed and validated against the specific regulatory framework of the IBM Data Science Professional Certificate exam before deployment. Correct answer is D. Develop custom functions and modules internally, ensuring each is rigorously reviewed and validated against the specific regulatory framework of the IBM Data Science Professional Certificate exam before deployment. Explanation. Scenario analysis. This scenario presents a professional challenge related to data privacy and security within the context of a data science project. The core difficulty lies in ensuring that the code used for data processing, specifically functions and modules, adheres to the regulatory framework governing data handling. The need for absolute priority in jurisdiction compliance means that any deviation from the specified regulatory framework, even if seemingly minor or for the sake of efficiency, can lead to significant legal and ethical repercussions. The professional must exercise careful judgment to balance the technical requirements of data science with the stringent legal obligations. Correct approach analysis. The correct approach represents best professional practice because it directly addresses the absolute priority of jurisdiction compliance. By ensuring that all functions and modules are developed and deployed strictly within the specified regulatory framework, IBM Data Science Professional Certificate exam guidelines, the data scientist upholds legal obligations and ethical standards. This approach prioritizes data integrity, privacy, and security as mandated by the exam's jurisdiction. It demonstrates a commitment to responsible data science practices, where adherence to established rules is paramount, preventing potential breaches of data protection laws and maintaining the trustworthiness of the data science work. Incorrect approach is analysis. An incorrect approach that involves using functions or modules from external, unverified sources, even if they appear to enhance performance, represents a significant regulatory and ethical failure. This is because the origin and compliance of these external components are unknown, and they may not adhere to the specific data handling regulations of the IBM Data Science Professional Certificate exam. Such an approach risks introducing vulnerabilities, violating data privacy principles, and failing to meet the absolute priority of jurisdiction compliance. It could lead to the mishandling of sensitive data, resulting in legal penalties and reputational damage. Another incorrect approach, such as implementing custom functions without thorough review for compliance with the exam's regulatory framework, also constitutes a failure. While custom development might seem controlled, the absence of a rigorous compliance check means that unintended data privacy or security risks could be embedded within the code. This oversight can lead to non-compliance, even if unintentional, and exposes the project to regulatory scrutiny. Finally, an approach that prioritizes speed of development over strict adherence to the specified regulatory framework for functions and modules is professionally unacceptable. This demonstrates a disregard for the absolute priority of jurisdiction compliance, which is a foundational requirement. Such a choice can lead to the deployment of code that inadvertently violates data protection laws or ethical guidelines, creating a direct conflict with the exam's mandate and potentially compromising the integrity and security of the data. Professional reasoning. Professionals in data science must adopt a proactive and compliance-first mindset. When developing or utilizing functions and modules, the decision-making process should always begin with a thorough understanding of the applicable regulatory framework. This involves 1. Identifying the specific jurisdiction and its relevant laws and guidelines. 2. Evaluating all components, whether custom-built or external, against these requirements. 3. Prioritizing compliance over perceived efficiency gains or novel technical solutions if they introduce any doubt regarding adherence to regulations. 4. Implementing robust review and testing processes to ensure that all code, including functions and modules, meets the mandated standards for data privacy, security, and integrity. 5. Documenting all compliance-related decisions and justifications. This systematic approach ensures that data science projects are not only technically sound, but also legally and ethically defensible, upholding the highest professional standards. Question 16. Analysis of a data scientist's interpretation of a hypothesis test result for a new pharmaceutical drug's efficacy, where the p-value obtained is 0.06 and the predefined significance level, alpha, was set at 0.05. Which of the following interpretations best aligns with sound statistical practice and regulatory expectations for demonstrating efficacy? Option A. The drug shows a statistically significant positive effect on patient outcomes, meeting the regulatory threshold for efficacy. Option B. The p-value of 0.06 is close enough to 0.05 to consider the drug effective, and the significance level can be adjusted to 0.07 to confirm this. Option C. The drug does not demonstrate a statistically significant effect on patient outcomes at the 0.05 significance level, and further investigation is needed to confirm efficacy. Option D. Since the p-value is greater than 0.05, the drug has no effect on patient outcomes. The correct answer is A. The drug shows a statistically significant positive effect on patient outcomes, meeting the regulatory threshold for efficacy. Explanation. Scenario analysis. This scenario presents a professional challenge because it involves interpreting the results of a hypothesis test in a context where regulatory compliance is paramount. The data scientist must not only understand the statistical implications of their findings, but also how those findings impact adherence to specific regulations. The challenge lies in translating statistical significance into actionable insights that satisfy regulatory requirements, avoiding misinterpretations that could lead to non-compliance or flawed business decisions. Careful judgment is required to ensure that the hypothesis test is conducted and interpreted in a manner that is both statistically sound and legally defensible. Correct approach analysis. The correct approach involves clearly stating the null and alternative hypotheses, selecting an appropriate significance level, alpha, performing the hypothesis test, and then interpreting the p-value in relation to alpha. If the p-value is less than alpha, the null hypothesis is rejected, suggesting that the observed effect is statistically significant and likely not due to random chance. This interpretation is crucial for regulatory compliance because it provides evidence to support or refute claims about a product, process, or system. For instance, if a regulation requires demonstrating that a new drug has a statistically significant positive effect, rejecting the null hypothesis that there is no effect provides the necessary evidence. This approach aligns with the principles of scientific rigor and evidence-based decision-making, which are often implicitly or explicitly required by regulatory bodies. It ensures that conclusions are drawn based on objective statistical evidence, minimizing subjective bias. Incorrect approaches analysis. One incorrect approach is to solely focus on the p-value without considering the predefined significance level, alpha. A low p-value alone does not automatically imply practical significance or regulatory compliance. It must be compared against a threshold set asterisk. Before asterisk, the test is conducted to control the risk of type I errors. Failing to do so can lead to overstating the significance of findings. Another incorrect approach is to conclude that a statistically insignificant result, p-value alpha, means there is absolutely no effect. This is a common misinterpretation. A statistically insignificant result simply means that there is not enough evidence to reject the null hypothesis at the chosen significance level. It does not prove the null hypothesis is true. This could lead to regulatory noncompliance if the regulation requires demonstrating a specific outcome, and the data, while not proving it, also doesn't disprove it sufficiently. A third incorrect approach is to adjust the significance level after observing the p-value to achieve a desired outcome, e.g., making a result significant. This is a form of p-hacking and is a severe ethical and regulatory violation. It undermines the integrity of the statistical process and can lead to misleading conclusions that could have serious consequences, especially in regulated industries. Professional reasoning. Professionals should approach hypothesis testing with a clear understanding of the business or regulatory context. This involves defining the problem, formulating specific, testable hypotheses, and predetermining the significance level alpha based on the acceptable risk of a type I error. After conducting the test, the interpretation of the p-value must be done in conjunction with alpha and the practical implications of the findings. If the results are statistically significant, the next step is to assess practical significance and regulatory implications. If not statistically significant, the conclusion should reflect the lack of sufficient evidence to reject the null hypothesis, rather than claiming the null hypothesis is true. Transparency in methodology and reporting is crucial, especially when regulatory compliance is at stake. Any deviation from standard statistical practice or attempts to manipulate results must be avoided. Question 17. The evaluation methodology shows that a data science team is tasked with building a predictive model for customer churn. They have identified several data points that appear to be extreme values in key features like average monthly spend and customer tenure. To ensure the model's robustness, the team is considering different strategies for handling these potential outliers. Which of the following approaches best reflects a professional and rigorous methodology for outlier detection and treatment in this context? Option A. Apply a sophisticated, unsupervised outlier detection algorithm without a thorough understanding of its assumptions, and then arbitrarily cap all identified outliers at the 95th percentile of their respective feature distributions. Option B. Conduct a comparative analysis of various outlier detection algorithms, e.g., Z-score, ICHR, isolation forest, and their corresponding treatment methods, e.g., removal, capping, imputation, evaluating the impact of each combination on model performance and interpretability before selecting the optimal approach. Option C. Immediately remove all data points flagged as outliers by a single, commonly used statistical method like the Z-score with a threshold of 3, as this is a standard practice for handling extreme values. Option D. Ignore all identified outliers, assuming they represent genuine but rare customer behaviors, to avoid discarding potentially valuable information, and to ensure the model captures the full spectrum of customer activity. The correct answer is B. Conduct a comparative analysis of various outlier detection algorithms, e.g., Z-score, ICHR, isolation forest, and their corresponding treatment methods, e.g., removal, capping, imputation, evaluating the impact of each combination on model performance and interpretability before selecting the optimal approach. Explanation. Scenario analysis. This scenario presents a professional challenge because the choice of outlier detection and treatment method directly impacts the integrity and interpretability of the data, which in turn affects the reliability of any subsequent data science models and business decisions derived from them. The challenge lies in balancing the need to address potentially erroneous or influential data points with the risk of removing valuable information or introducing bias. Careful judgment is required to select a method that is appropriate for the specific dataset, the business context, and the intended use of the model, while adhering to ethical data handling principles. Correct approach analysis. The correct approach involves a comparative analysis of multiple outlier detection and treatment methods, considering their impact on the data distribution and model performance. This is best professional practice because it acknowledges that no single method is universally superior. By evaluating different techniques, e.g., Z-score, ICHR, isolation forest, DB-scan, and their corresponding treatment strategies, e.g., removal, capping, transformation, imputation, data scientists can empirically determine which combination yields the most robust and interpretable results for the specific problem. This iterative and evidence-based approach aligns with the principles of responsible data science, ensuring that decisions are data-driven and justifiable. It promotes transparency and allows for a clear understanding of how outliers were handled and the potential implications. Incorrect approaches analysis. Applying a single, predetermined outlier detection and treatment method without comparative analysis is professionally unacceptable. For instance, blindly removing all data points identified as outliers by a single method, such as the Z-score method with a strict threshold, can lead to significant loss of valuable information if those points are genuine, albeit extreme, observations. This can introduce bias and reduce the generalizability of the model. Ethically, This approach fails to adequately explore the data and could lead to misleading conclusions. Another incorrect approach is to ignore outliers altogether. While sometimes outliers might be considered noise, ignoring them can lead to models that are highly sensitive to these extreme values, resulting in poor performance and unreliable predictions. This can have significant ethical implications if the model is used for critical decision-making, as it might systematically misrepresent the underlying phenomena. A third incorrect approach is to apply a complex outlier detection method without understanding its underlying assumptions or limitations, and then treating the identified outliers in a simplistic manner, such as arbitrary capping. This can lead to unintended consequences and a loss of data integrity. Professionally, this demonstrates a lack of due diligence and can result in a model that is not fit for purpose. Professional reasoning. Professionals should adopt a systematic and iterative approach to outlier detection and treatment. This involves 1. Understanding the data and the business context. What constitutes an outlier in this domain? What are the potential causes of outliers? 2. Exploratory data analysis (EDA). Visualize the data to identify potential outliers and understand their distribution. 3. Comparative method evaluation. Test several outlier detection algorithms, e.g., statistical methods, density-based methods, tree-based methods, and assess their sensitivity and specificity for the given dataset. 4. Treatment strategy assessment. For each detection method, evaluate different treatment strategies, removal, transformation, imputation, and their impact on data distribution and downstream model performance. 5. Model performance metrics. Use appropriate metrics to evaluate how different outlier handling strategies affect the performance of the intended model. 6. Documentation and justification. Clearly document the chosen outlier detection and treatment methods, along with the rationale and the results of the comparative analysis. This ensures transparency and reproducibility. Question 18. The assessment process reveals that a critical data pipeline responsible for cleaning and validating customer transaction records is experiencing performance issues and occasional data integrity lapses. The current implementation uses a series of sequential checks, and when an error is detected, it attempts a correction. However, it's unclear how many correction attempts are truly needed for a given record to become fully compliant with all validation rules. The development team is considering refactoring this section to improve its reliability and efficiency, which control flow strategy would best address the dynamic and potentially iterative nature of data validation and correction. Option A. Implement a while loop that continues to execute the validation and correction logic as long as the data record is flagged as invalid, with a clear condition to exit the loop once all checks pass. Option B. Employ a for loop that iterates through a predefined list of validation rules, applying corrections, but without a mechanism to re-evaluate the data's overall validity after each correction attempt. Option C. Utilize a series of nested if-else statements to sequentially check for each possible validation error and apply a correction if found, without any looping mechanism. Option D. Replace the current logic with a for loop that iterates a fixed number of times, assuming that a reasonable number of iterations will suffice for most records. The correct answer is A. Implement a while loop that continues to execute the validation and correction logic as long as the data record is flagged as invalid, with a clear condition to exit the loop once all checks pass. Explanation. Scenario analysis. This scenario presents a common challenge in data science projects where efficiency and accuracy are paramount, but the underlying data processing logic can become complex. The professional challenge lies in selecting the most robust and maintainable control flow mechanism for a critical data validation process. Misjudging the appropriate loop structure can lead to performance bottlenecks, increased debugging time, and potential data integrity issues, all of which have significant implications for the reliability of the insights generated. The need for clear, concise, and efficient code is amplified when dealing with sensitive data or processes that impact downstream applications. Correct approach analysis. The correct approach involves using a while loop with a clear exit condition based on the validation status of the data. This represents best professional practice because it directly addresses the dynamic nature of data validation. A while loop is ideal when the number of iterations is not known in advance, but depends on a condition being met. In this case, the loop should continue as long as there are validation errors. This ensures that all necessary checks are performed and corrections are attempted until the data meets the required standards. This approach promotes code readability and maintainability, as the loop's purpose is immediately evident from its condition. It also aligns with the principle of iterative refinement, a core concept in data processing where data is progressively improved. Incorrect approach is analysis. An incorrect approach would be to use a for loop with a fixed number of iterations, such as iterating 100 times. This is professionally unacceptable because it fails to guarantee that all validation errors will be addressed. If the data requires more than 100 iterations to become valid, the loop will terminate prematurely, leaving invalid data in the system. Conversely, if the data becomes valid within fewer than 100 iterations, the loop will continue unnecessarily, wasting computational resources and potentially introducing unintended side effects if the validation logic has side effects. This approach lacks adaptability and does not reflect a deep understanding of the problem's dynamic nature. Another incorrect approach would be to use nested if-else statements to handle each potential validation error sequentially without any form of iteration. This is professionally unsound because it leads to highly unmanageable and unscalable code. As the number of validation rules increases, the complexity of the if-else structure grows exponentially, making it extremely difficult to debug, modify, or extend. It violates the DRY, don't repeat yourself, principle and creates a brittle codebase that is prone to errors. A third incorrect approach would be to use a for loop that iterates through a predefined list of validation checks, but without a mechanism to re-evaluate the data after a correction. This is professionally deficient because data validation is often an iterative process. Correcting one error might introduce another, or reveal a previously masked error. Without a loop that continues as long as errors persist, the process will not achieve full data integrity. Professional reasoning. Professionals should approach control flow decisions by first understanding the nature of the task. If the number of repetitions is fixed or can be easily determined, a for loop is often suitable. However, for tasks where the termination condition is dependent on the state of the data or a process outcome, a while loop is the more appropriate and professional choice. The decision-making process should prioritize clarity, efficiency, and robustness. Always consider how the code will behave with edge cases and varying data conditions. When in doubt, opt for the control flow that most directly models the problem's logic and allows for graceful handling of dynamic outcomes. Question 19. Research into the most effective way to store and manage customer order history data for a new e-commerce platform, considering that the data includes structured fields like order ID, customer ID, and product details, as well as potentially unstructured notes from customer service interactions. Option A. Utilize a document database that allows for flexible schema design, storing each order as a separate document with nested information, including customer service notes. Option B. Opt for a simple flat file system like CSV to store all order data, as it is easy to read and write. Option C. Employ a graph database to model the complex relationships between customers, products, and their purchase history, allowing for intricate network analysis. Option D. Select a relational database management system, RDBMS, that enforces a strict schema, ensuring all order details are consistently structured and relationships between customers, orders, and products are clearly defined. The correct answer is D. Select a relational database management system, RDBMS, that enforces a strict schema, ensuring all order details are consistently structured and relationships between customers, orders, and products are clearly defined. Explanation. Scenario analysis. This scenario is professionally challenging because it involves a critical decision about data storage and management that has direct implications for data integrity, accessibility, and compliance. The choice of database technology is not merely a technical one. It carries significant weight in terms of how data is organized, queried, and maintained, which in turn affects the reliability and trustworthiness of insights derived from that data. A data scientist must balance technical feasibility with the practical needs of the organization and potential regulatory considerations, even at an introductory level. Correct approach analysis. The correct approach involves understanding the fundamental differences between relational and non-relational databases and selecting the one that best aligns with the nature of the data and the intended use. Relational databases, with their structured schemas and ACID properties, atomicity, consistency, isolation, durability, are ideal for data that has well-defined relationships and requires strong consistency, such as financial transactions or customer records. This ensures data integrity and reliable querying, which is paramount for accurate analysis and reporting. For the IBM Data Science Professional Certificate, understanding these foundational concepts is key to making informed decisions about data management. Incorrect approach is analysis. Choosing a database technology without considering the data's structure or intended use is a significant professional failure. For instance, opting for a non-relational database when the data is highly structured and requires complex joins and transactions would lead to data integrity issues and inefficient querying, undermining the analytical process. Conversely, forcing unstructured data into a rigid relational schema can result in data loss or an overly complex and unmanageable database. These choices, while not directly tied to specific regulations in this introductory context, represent a failure in professional due diligence and can lead to downstream compliance issues if data is not managed appropriately. The lack of a systematic evaluation process also indicates a deficiency in professional reasoning. Professionals should employ a decision-making framework that begins with a clear understanding of the data characteristics, structured, unstructured, semi-structured, the intended use cases, reporting, analytics, real-time processing, and the required level of data integrity and consistency. This involves asking critical questions. What kind of data am I dealing with? And what do I need to do with this data? Based on these answers, one can then evaluate different database paradigms, relational vs. non-relational and specific technologies, considering their strengths and weaknesses in relation to the project's requirements. This systematic approach ensures that the chosen solution is robust, efficient, and supports the overall goals of the data science initiative. Question 20. Quality control measures reveal that two distinct data science tools, commonly used for predictive modeling within the organization, are producing significantly different performance metrics on a critical customer churn prediction task. One tool consistently reports higher accuracy, while the other demonstrates better precision and recall for identifying at-risk customers. The data science team needs to decide which tool to prioritize for future model development and deployment. Option A. Ignore the discrepancy as a minor statistical fluctuation and continue using the tool that has been historically favored by the team without further investigation. Option B. Select the tool that exhibits better precision and recall, even if its overall accuracy is lower, without fully understanding the trade-offs or the specific business context for prioritizing these metrics. Option C. Conduct a thorough investigation into the underlying data preprocessing steps, algorithm implementations, and hyperparameter tuning for both tools to understand the root cause of the performance divergence and determine the most suitable tool based on the specific business objectives of minimizing churn. Option D. Immediately adopt the tool that reports higher overall accuracy, assuming it is inherently superior for the churn prediction task, and discontinue further evaluation of the other tool. The correct answer is C. Conduct a thorough investigation into the underlying data preprocessing steps, algorithm implementations, and hyperparameter tuning for both tools to understand the root cause of the performance divergence and determine the most suitable tool based on the specific business objectives of minimizing churn. Explanation. This scenario presents a professional challenge because the data science team has identified a discrepancy in the performance of two widely used data science tools. The core of the challenge lies in determining the most appropriate course of action when faced with potentially conflicting results from different technologies, especially when these tools are integral to critical business processes. The need for careful judgment stems from the potential impact on decision-making, resource allocation, and the overall reliability of data-driven insights. The correct approach, which involves a systematic investigation into the underlying causes of the performance difference, represents best professional practice. This approach aligns with the principles of data integrity and responsible data science. By thoroughly examining factors such as data preprocessing steps, algorithm implementations, parameter tuning, and the specific characteristics of the datasets used, the team ensures that the chosen tool is not only effective, but also appropriate for the task at hand. This methodical investigation prevents the premature adoption or rejection of a tool based on incomplete information, thereby upholding the ethical obligation to provide accurate and reliable insights. It also implicitly adheres to the spirit of good governance and due diligence expected in professional data science practice, ensuring that technology choices are evidence-based. An incorrect approach would be to immediately favor the tool that appears to perform better without understanding the reasons for the disparity. This could lead to the adoption of a tool that is either misconfigured, less robust for the specific problem, or whose perceived superiority is an artifact of a flawed evaluation. Such an approach risks introducing subtle biases or errors into the analytical pipeline, potentially leading to flawed business decisions and a loss of stakeholder trust. This failure to investigate thoroughly constitutes an ethical lapse in due diligence and a disregard for the principles of scientific rigor. Another incorrect approach would be to dismiss the discrepancy as a minor anomaly and continue using the previously favored tool. This ignores potential underlying issues that could impact future analyses and may represent a missed opportunity to optimize the data science workflow. Ethically, this demonstrates a lack of commitment to continuous improvement and a failure to address potential risks to data quality and analytical accuracy. A third incorrect approach would be to immediately switch to the tool that shows better performance without any validation or further testing. This hasty decision-making process, driven by superficial results, bypasses essential validation steps. It fails to account for potential overfitting, data leakage, or other methodological flaws that might be inflating the performance metrics of the new tool. This can lead to unreliable outcomes and a breach of professional responsibility to ensure the robustness of analytical methods. The professional reasoning process for such situations should involve a structured problem-solving approach. First, clearly define the observed discrepancy and its potential impact. Second, formulate hypotheses about the root causes of the difference. Third, design and execute experiments to test these hypotheses, focusing on isolating variables and controlling for confounding factors. Fourth, document all findings and decisions transparently. Finally, communicate the results and the chosen course of action to stakeholders, explaining the rationale and any implications for ongoing projects. This systematic and evidence-based approach ensures that decisions are sound, ethical, and professionally defensible.